Hi all, this is Alan with Bothell STEM Coach, and today we are doing some more AP Physics 1 free response questions, and we are looking at electrostatics here. So before you attempt to do the problem, I want to eliminate some questions that you would have to do, anything related to electric potential. But I think the rest of the problems you should be able to do. So again, I suggest you pause the video, try to do the problem, and then come back after you've tried the problem. The square of a side above contains a positive point charge Q fixed at a lower left corner and a negative point charge Q at other three corners of the square. Point P is located at the center of the square. On the diagram, indicate with an arrow the direction of the net electric field at point P. So basically, you're going to sum the electric field from each of these. So for example, at point P, electric field always flows from positive to negative charge. So from this charge, okay, so like for a positive Q charge, the electric field's lines radiate outward like this, okay? And for a negative charge, they flow inward. The electric field lines flow inwards. And then you just simply sum up the electric fields from this guy. So this guy, I'm going to draw the components and then I'll draw the answer, is going to have an electric field flowing outward from this guy, is going to have one flowing inward from this guy, flowing inward from this guy, and then this one is going to be flowing inward, so it's going to be like double like that one on top. So the sum of all of these, because they're all kind of the equidistant away from the center, is it's going to be a vector like this. These two vectors will cancel each other, and the sum of these will be like this. Okay, so that will be the net. And the length is not super important. Like it doesn't have to go all the way there. It can go part way there, but that's just the direction it's going to be. Okay. Derive expressions for each of the following in terms of the given quantities and fundamental constants. The magnitude of the electric field at point P. So, to find the magnitude of the electric field, the magnitude of electric field due to any point charge particle is K Q, I'd use little q, over R squared. Okay? That's for a point charge Q. Now, what we said is that these two are going to cancel. So I just need to compute the electric field from this guy and the electric field from this guy. Well, from the positive Q, the electric field amount is equal to K times Q over this distance. Well, if here you're going to have to use some right triangle. If, let's see, I think they're saying, oh, each side is A, okay? Each side is A. So this is 1/2 A, and this is 1/2 A. The distance from here to here by Pythagorean theorem is actually 1/2 A times square root of 2. So this distance is A, 1/2 A times square root of 2. Because this is a 45-45 triangle. 1/2 A root 2. And so that's equal to, let's see, 2kq over square root of 2a. And if you want to rationalize it by multiplying by root 2 over root 2, you'll find that this is 2 root 2, so it becomes square root of 2 kq over a. Okay? Now that's just due to the positive charge. I'm going to have the exact same one due to the negative charge, and then it'd be the same amount. So like I said, this arrow becomes doubled then. So my total electric field then is equal to 2 root 2 kq over a. Okay. So we don't need to do electric potential unless you're doing AP Physics 2 and you want to practice. A positive charge is placed at point P. It is moved from point P to point R, which is the midpoint of the bottom of the square. As the charge is moved, is the work done by the electric field positive, negative, or 0? Well, let's see. It's a positive charge. So what it would like to do, if for let's see, I want the work, be careful about this, the work done on it by the electric field. So the work done by the electric field is its force times its distance. Okay, the electric field is applying a force on a positive charge. The force would be in the direction of the electric field. Okay, and we're moving it downward. This is my D. Okay, so because the force component that's parallel to D is against the direction of D, the work would be negative. Because remember, the work is always force. It's force times distance cosine theta. What that, like, sometimes people write that formula. That formula is not super useful. Basically, if you're doing force, if the direction is in the force are the same direction, I'm doing positive work, and if it's the opposite direction, I'm doing negative work. So in a positive charge, the force is this way. It's because it's in the direction of the electric field. See, it would be different if it was a negative charge. If it was negative charge, the force would be this way. But it's a positive charge, so the force is this way. Okay, and so because the distance that it has to travel is opposite of the against the direction of the force, the work is negative. Okay. Describe one way to replace a single charge in this configuration that would make the electric field at the center of the square equal to 0 and justify your answer. Okay. Now, if I made this one a negative Q charge, then all the vectors that I came up with would cancel. Okay. So you could do that. You could also make, instead of doing that, you could also make this one a positive Q charge. Then the vectors would all cancel again, and the electric field would still be 0. So, yeah. And then we're going to skip D2. So, hope you found that helpful. I'll see you in the next video. Thanks for watching the video, guys. Please leave a comment, like, or subscribe below to catch up more of the content. And see any links below. I offer free homework help on Twitch and Discord. See you guys in the next video.